Okay, this question says, what are all values of p for which this improper integral converges? And then we have all these options. So sorry about the way it all formatted, but we'll look at this later. So again, we see that we look at a p integral. A p integral has this property, which is that this will converge if p is bigger than 1, and it'll diverge if p is less than or equal to 1, and I guess bigger than 0, to be a proper p integral here. So when will this converge? We'll just go apply the test of that exponent, right? We need that exponent, whatever it looks like, this time it's a quadratic, it has to be bigger than 1. So we need p squared minus 2p plus 2 to be bigger than 1. And now we just try to get the condition on p that makes this true. So minus 1. Okay, and then this is all rigged to factor, so I believe that factors to p minus 1 squared. I think students sometimes have a hard time with inequalities. There's a couple ways you can think of this. One is we're squaring something, and so when you square something, that'll always be greater than 0 unless p is equal to 1, right? So like if p equals, so you can kind of just logically think of that if you want. Like we're squaring this expression. Anything you square, any number you square is greater than 0 unless that number is 0. So like this is true. That's just kind of using some number sense. So this is true for all values of p unless or except p equals to 1, because that will make it 0. Okay, so that actually suggests our answer up here, which is E, right? Notice what I just said is the same as this. Let me just linger on this for a little bit to help you out with inequalities if you're struggling on them. The other thing you can do is you can make a number, like let's just make a number line. Okay, this is like our expression here. Like when is p minus 1 squared? Okay, first let's set it equal to 0. What makes it 0? When p is 1. Okay. Maybe I'm going to call this like something f of p or something. Okay, and so now what you do is you take your expression f of p here and just start plugging in numbers on either side of 1. So for example, if when I plug in 2, I get 2 minus 1 squared, which is a positive. And if I plug in negative 1, you get negative 2 squared, which is positive. And so we see everywhere except here, this inequality is true, right? It's positive everywhere. So either way, okay, if you think of it that way, then that's how you get that inequality. Actually, maybe while I'm lingering on this, if you think graphically, just note that p minus 1 squared is a parabola. It's like x squared with shifted right 1. So it's going to look like this. If your brain thinks graphically, the function p minus 1 squared is a parabola, and the only time it's not positive is right there at 1. So whether you think any of these approaches is totally legitimate. It's actually a nice synthesis of a lot of mathematical like ways of thinking, I guess. Anyway, the answer is E. So hopefully one of those ways kind of gave you something to think about.